Math isn't difficult. Math is fun. I am Nilakanta Bhanu Prakash and I am the fastest human calculator in the world. And we are exploring infinities. Exploring infinities is here in front of you to give you a mathematics learning experience like never before. With expert trainers from around the country, we are here to make you learn math the right way.
Hi, I'm Anshika from Exploring Infinities, and I'll be helping you with this chapter named Quadratic. Let's get started. So, in this chapter, basically, I want you to extract some knowledge that you already have. You probably know what exactly are polynomials by now. So, in polynomials, you studied about linear polynomial, a quadratic polynomial, a cubic polynomial. So, I want some knowledge to be extracted from there. So if you remember what exactly were these polynomials. So whenever your polynomials, you used to check the highest power, the degree of the polynomial. So whenever the highest power of your variable used to be 1, you used to say that it's a linear polynomial. When it used to be 2, you said that it's a quadratic polynomial, and when it was 3, you said that's cubic polynomial. So I want you to take out the quadratic polynomial part. So in that quadratic polynomial, I'll just add one more line. I'll say that when you equate that particular quadratic polynomial to 0, you'll get your quadratic equation. That's what this whole chapter is all about. You'll be dealing with quadratic equations, which are actually quadratic polynomials when equated to 0. So this was the entire crux of the chapter, that what exactly is quadratic polynomial. So as we move forward, we will see how exactly are we going to deal with these quadratic equations. Okay, so let's see how exactly do we get these quadratic equations from your real life examples. So for example, you own a piece of land. Okay, you know that the area of the land is 300 meter squares. So you know that you have a land, you are the owner, so you know the area of the land. So now you want to build a hall in it. You know, someone wants to invest, and on your building that you're going to build. So his requirement is that the length of the hall should be one more than twice its breadth. So his only condition is that he'll invest into your building and stuff, everything he'll do, but he wants that the length should be one more than twice its breadth. So you know how to deal with such problems, word problems, right? So this is for a word problem only, kind of word problem only. So what do you have exactly right now? You know that the area is 300 meter squares. Okay, so now the investor wants that the length should be one more than twice its breadth. So what do? You take your breadth to be probably x, then your length will be one more than twice the breadth, that's x. So you have the relationship between L and B, your length and breadth, and you know that the product of these two is your area. So you tell the investor that L into B is A. So you have 1 into 2x multiplied by x is equal to 300. So when you simplify this equation, you exactly have 2x square plus x minus 300 equal to 0. So now if you have a look, this is a quadratic equation. The LHS of this particular equation is a quadratic polynomial, and I told you whenever you equate your quadratic polynomial to 0, you have your quadratic equation. So this was one of the very basic example that how quadratic equations are basically developed. So now I'll demonstrate a piece of sheet paper, something like this. So your granny made a box for you. Okay, so she said that she has this square metal sheet lying there. She wants to make a box out of that particular metal sheet, square metal sheet for you. So she made this box for you. Okay, just ignore my drawing and stuff. This is the box she made for you. So now you asked your granny, like, how exactly did she made this particular box for you? So she told you that she actually had this metal sheet with her, but she cut out such small squares from each side of this metal sheet, square metal sheet. So she actually cut out this metal sheet from this side, from this side, from this side, and from this side. So she has 4 such square metal sheets cut out from the main square metal sheets. So she said that the square sheet that she cut out from the main square sheet, the length of that particular square sheet was 9. So you know that this particular length is 9. That is, the square that she had cut out from the metal sheet is of 9 centimeters. So you know that this particular part is actually 9 meters. Sorry. Okay. So you have this. Now, Granny said that she knows the volume of the new box. That is, this particular box that she has made for you. She knows the volume. The volume is 144. Okay. So now she's asking you what exactly, she doesn't remember what exactly was the length of the real square metal sheet. So she wants you to find this particular length. Okay. So for this particular length, you know that what is this? This is a cuboid. Okay, so you know that the height of this particular cuboid is 9. How? From here. You know that this is the height. So you have this height. So now you have to find this particular length, right? So you say that this is x. So if I take this entire length of the original metal sheet to be x, what will be the length, the length and breadth of the cuboid, the box that she has made? If this entire thing is x, she's cutting out 9 from here, 9 from here. So what is left here? It's x minus 9 minus 9. So it's x minus 18. So remember, she has this particular square thing as the base of her box. So it's x minus 18 and x minus 18 as the length and breadth both of the box. So you have your L, you have your B, you have your H, and you know the volume 144. So you have the equation volume LBH. So you say 144 is equal to x minus 18 into x minus 18 multiplied by 9, which was the height. So if you try simplifying this equation, you have x minus 18 square is equal to 16, which you can say x square minus 36x plus 324 is equal to 16. If I simplify it further, I have x square minus 36x plus 308 equal to 0. So here you again have a quadratic equation. So these are some examples on how such quadratic equations are developed. So let's do the exercise, our exercise 5.1, where we actually have to determine if the equations that they have given us are quadratic or not. So let's get started. So this is exercise 5.1. So as you can see, I have highlighted a few questions. So let's do that. So the question number 1 says, check whether the following are quadratic equations or not. So I'll write the answer. We'll simplify these equations first of all into, the simplest form that we both know, that is ax square plus bx plus c equal to 0. Okay, so in such cases, so it becomes easy for us to identify if they're actually quadratic equations or not. So the first one is, says x plus 1 whole square is equal to 2 times x minus 3. So if I simplify this, I have x square plus 1 plus 2x equal to 2x minus 6. Okay, so if I simplify this further, I have x square plus 7 equal to 0. So as you can see, this is the equation. Okay, it is a quadratic equation. Why? Because the highest power of my variable is 2. Here my bx term is 0. It's okay. It's okay if my bx term is 0, my x square term is not 0. Okay, so I have x square with me, and that is the highest part available in this equation, so it becomes a quadratic equation. So the answer is yes. Next one says x square minus 2x is equal to minus 2 multiplied by 3 minus x. So if I simplify this, I have x square minus 2x is equal to minus 6 plus 2x. Again, if I simplify it, in the form of ax square plus bx plus c, I have x square minus 4x plus 6 equal to 0. So as you can see, this is in the general standard form, ax square plus bx plus c equal to 0. So yes, this is also a quadratic equation. So let's see this last one example. This is x minus 2, x minus 1 equal to x minus 1, x plus 3. So if I simplify this, I have, if I multiply this and all, so I have x square minus x minus 2x plus 2 equal to x square plus 3x minus x minus 3. So if I simplify this, my x square term gets cancelled. So I have basically 5x minus 5 equal to 0. And in this equation, you can see my highest degree is basically 1. So this is not exactly a quadratic equation, but a linear equation. So my answer will be no. So this was my exercise 5.1, question number 1. So let's do question number 2. So the question number 2, first part says the area of the rectangular plot is, so basically in this question you have to understand the situation and form the quadratic equations. Like we did a few examples in the beginning, so it's the same only. You have to just make the quadratic equations for such situations. So the area of the rectangular plot is 528 meters square. The length of the plot is 1 more than twice its breadth. We need to find the length and breadth of the plot. So again, it is similar to the question we did in the beginning, the example we did. So this time just the area is different. So it says that the area is 528 meters square, and the breadth, again the x, L will be 2x plus 1. So according to the question, if I simplify it, I have 2x plus 1 multiplied by x equal to 528, which gives me 2x square plus x minus 528 equal to 0. So I have this quadratic equation with me. So the question said that we had to find the length and breadth basically. So we don't know how exactly shall we solve this quadratic equation. We'll study about, so this is again one of the main questions and the problems we'll deal in this chapter, that how exactly are we going to solve these quadratic equations. How exactly are we going to find the length and breadth of the particular plot that we own. Okay, so this is just one of the examples. So we'll study gradually in this chapter that how are we going to solve these quadratic equations. So the next question is third. It says that Rohan's mother is 26 years older than him. The product of their ages after 3 years will be 360 years. We need to find Rohan's present age. So let's just say that Rohan's present age is x. Okay, so we have Rohan's present age as x. So if Rohan's present age is x, the question says that his mother is 26 years older to him. So we have his mother's age as x plus 26. Okay, so we have x plus 26. So we have the relationship between Rohan's mother's age and Rohan's present age. So it says after 3 years. So let's write down after 3 years. Rohan's age will be what? If you are, I'm 30 years old right now, I'll be 33 after 3 years. So how exactly am I going to get this? My present age plus 3. In a similar fashion, I'll say Rohan's present age x plus 3. Similarly, mother's age will be x plus 26 plus 3, that's 29. So we have the relationship between Rohan's age after 3 years and the Rohan's mother's age after 3 years. Then the question says the product of the ages after 3 years will be 360. So simply we have to multiply this part and this part and say that it's 360. So it's x plus 3 multiplied by x plus 29 equal to 360. So if I simplify this, I have x square plus 32x plus 87 is equal to 360, which on further simplification gives me x square plus 32x minus 273 equal to 0. So again we have a quadratic equation over here, but we don't know yet how to solve it. That is, the question says that we need to find the Rohan's present age. So for that we don't know how to solve this. So we'll gradually see on how to solve such quadratic equations that we have actually learned to form today.
And so we come to an end to today's lecture. Thanks a lot for watching this, and stay tuned for the upcoming ones. Don't forget to follow @fastesthumancalculator and @exp.infi on Instagram, and subscribe to our YouTube channel.